Okay. I'm not doing anything. All right, guys, if you can hear me, I'm getting started now. So I hope you all learned a few lessons as you were trying to do this. First of all, how many of you watched the 3 videos? Any team watched the videos of the text snake and Nougat? And if you haven't, please take the time to watch it. Today was the first time in this boot camp that I didn't give you pretty much the whole solution, but I asked you guys to try to solve it on your own. And if you did that, you must have realized that the going gets tough pretty quickly in this space. OCR is one of the more frustrating spaces. Visual multimodal learning at this moment is very raw. We are trying to do visual question answer. The space is visual question answer. Actually, let me change the color of this background too. Guys, please pay attention here. Yeah. So when we talk about visual question answer, you realize that many things are involved here. Let's break it down into first just understanding what text is there. Understanding text. Text, and then answering questions on this. Guys, I'm getting a lot of cross conversation here. Yeah. So understanding the text itself requires as a precondition that you know where the text is. Where is the text? So the OCR part, traditionally people used to think that what they have to do is OCR, optical character recognition, which means founding the bounding box, right? Or let's say the word OCR is there, finding where is the text, and once you find the text, then you decipher what's there in the text. If you look at the evolution of this field, and in some way, by using the different libraries you're going through it, you must have noticed, and if you go to the oldest one, RCNN, what it does is, it says, let us use CNN to propose regions where the text is, then use some form of either RNN or something, some decoder to figure out what is written there. It's the oldest one, right? And that's why I put it in your list of papers as the first paper to study. If you study that, you will notice that RCNN itself historically was a huge shift or a huge improvement over what people were trying to do, Hog, etc., etc. What people used to do in the traditional world is they used to do feature point extraction. And feature point extraction is still going strong. It is given an image, you find all the interesting points, all the interesting features in it. And people somehow thought that if you did that in the classic computer vision, it should help you with OCR. One of the lessons that deep learning brought is you don't need to. Even with CNNs, we learned that you can actually forget about this. And if you read the RCNN paper, which I invite you to read, you'll realize that the message there is forget about all of this, because the performance improvement when it comes to OCR or optical character recognition, you hit a plateau. You're not able to make progress beyond a certain point. So RCNN and its faster versions were used for for a long time. Then the next stage in the progression of these ideas was somebody said, okay, why can't I use a transformer? Right? So how would I do it with a transformer? I can do optical character recognition with a transformer directly. And so what you do is they said, okay, look at this fact. I can take an image in which the word, let us say that the word cow is written. I can convert it using a VIT kind swing transformer, using a swing transformer to what? To a hidden vector of the image. We have covered this territory, isn't it? Once we covered this, so you use one transformer to encode, and then you use another transformer to decode. You take a decoder part of the transformer, right? Essentially, and what do? When you decode, first thing is you have to figure out what this is, T. And then based on the hidden vector, HI, plus, because it's a causal model, you can feed it back in. You can start deciphering or decoding the text. Does that make sense? And that is something that you will find. I would like to cover the TR OCR paper, but today I've been seeing how much progress you guys have been making with the project. And we will see it at a more sustained level. I'll have all of you guys present. First, how much progress you made, but more than that, what struggles you face. Because today, the lesson that I guess the main lesson that I didn't tell you guys will learn is that it's terribly frustrating. The libraries don't quite work well with each other. How many of you agree with that? Everybody. Yes. Welcome to the world of multimodal learning. Right. Welcome to the world of multimodal learning. At this moment, it's very frustrating to get your environment just right. And when you do get your environment just right, immediately freeze it, pip freeze that Conda environment into a requirement file. That requirement file is worth its weight in gold because, right? Yeah, but only for a little while, because next week it will be outdated. Right? Versions will change, something else will come up, you'll get tempted to use something else, right? But for a little while, that works. But anyway, so this is the transformer-based approach, OCR, and you saw transformer-based OCRs come out, right? Along the way, people realize that, see, if you do that, sometimes, especially receipt data, if you look at an invoice or receipt, it has a tabular structure. So maybe you need a layout sensitive, right? A layout sensitive OCR. And then you start looking at the layout LM, V1 to 3, right? 1 to 3. These models, because they are able to do a little bit better at the task, right? And you must have noticed that when you're talking about invoice, layout LM, V1 to 3, 1 or 2 or 3, I think 2 or 3 is what most of you are trying with, did better. How many of you succeeded with that?
We are just entering into that.
You're just entering into that. Okay. It will work well for receipt, but the moment you go to handwriting text, it will do badly. Why? Because it isn't meant for it. Right? It won't do as well with that. Right? Then the final approach is you got rid of the CNN, you went to transformer, and then I'm just giving you a recap. Then you go to the donut-like approach, which basically says forget OCR altogether. Right? Treat it as a game of multimodal learning. It's multimodal. Right? What you do is you just encode the image, again, encode the image, and then you can directly engage or interact with it, and no OCR, like no first finding the bounding box of the characters, etc. You can directly prompt it right? You can directly prompt it to get answers. That's pretty much it. Right? The message of Donut is that you could prompt it and get answers from it. It's basically somewhat in the flavor of Blip to a Lava or something like that, right? Like that. So it gives you a certain degree of success on the rare occasion that your environment does work. Now, what I would like to do is, I know that all of you are struggling. Now, one thing, let me ask a baseline question. This, handwriting recognition, how many of you got, sorry. How many of you got quite a bit of success with handwriting recognition? How many of you did the handwriting recognition part and got any success whatsoever? What's happening?
Yes, we did for the remote team Kahoa.
Oh, okay, wonderful, wonderful. Would you like to, actually, why don't we start? Now is the time for presentations. So let us all start making those presentations. My screen is jumping around for a little bit. I don't know what's going on, so I'm going to kill it and start it again. But let's start with the presentations now, team by team. So perhaps we can start with the Kahoa team. And then I want to sequence the teams here. Somebody, which would be the next team? Jenna, your team? Vector Smiths? Okay, show where you guys are. And then this room is, which team is this room? I2 something, right? Yeti. And Yeti, you guys go next. And then the Heisenbergs go after that. Does that look fair? Okay, so we have a sequence. So let's start with that. I'm going to now move to that. I guess, should I start a new recording or just let it continue? Okay, let's just continue and have all the presentations in one. Sarah, would you like to take over, share your screen and share your experiences, how far you are, walk through your code and so forth?
Sure. I had to switch from my phone back to I was grabbing coffee, so I apologize for that. Lily's going to be our spokesperson, and I will share my screen. Let's see. Do this one. Okay, I guess we'll start on our hand. No, Lily, you want to walk us through it, and I'll run the code.
Yep. So for our handwritten note, we use this model, the LLM document model. We use the same code for our.
We are not seeing your screen.
Oh, I pulled it off.
Okay, much better.
There we go. Perfect. Okay, so this is the handwritten document that we used. It's from this class actually. So our questions that we had were, what is it epoch? What is it training? And we were able to get it to work great. Perfect. As well as our receipt questions, we the original one we did worked, but when we switched out for a donut model, it worked a little better, getting us better answers.
With the donut model. Okay, good.
Yeah, with our different, we used a vision encoder model and then also the donut model.
Okay.
And we were able to get all the right answers and such.
Do you remember which specific vision encoder model you used before donut?
Right, there are.
This is a donut model. Donut. Did you use something before that?
On our other one, we had two different ones. We used this imperial layout document model.
Very good. Very good. And donut beats in layout, doesn't it?
Yes. Worked a lot better.
That is in accordance with what's the general observation. Donut does beat layout, question answer. And one nice thing that I noticed is that you guys directly use the Hugging Face pipeline which is the recommended way because it standardizes. Most model conform to the Hugging Face API, and so using it does make your code much simpler, isn't it?
Yes, a lot easier.
Yes, very good. So this is good. And did you feel that the answers were coming out right? How did it do with your receipts?
It worked really great. It worked better when we used the two different models, but they both were good.
Donut as well as the layout LM both gave you good answers on the receipt, is it?
Yeah.
Okay. On the layout, did you use layout V2 or V3? Layout LM V2 or V3?
No, we used the way this is set up here.
Okay. No, this is the donut. This is the donut. Where is
Yeah.
the?
We didn't get into the other layouts. We tried them, but we were running into environment and other issues working towards getting that to work.
Okay, yeah, I can see that you use V2. V2 here, right? V3 is out. You might also want to play with V3. But no matter what, I think Donut is going to beat the layout system anyway, because Donut takes a more contemporary multimodal approach to the whole thing.
One thing to note on this that I thought was interesting is if we go to, and this is Lily's notes on here, but we asked the question down here, what is a hyperparameter? And her equal is a little bit smaller. So it gave the answer as the line below. But then when we asked what IID is, it gave the correct answer back. So interesting observation.
Right. Nice. And could I see the text? And can we run this code if I were to ask it a different question?
Yes.
Okay. Let's look at that notes again. Now, this is well done. This is really well done. One question is how many times? So suppose I would ask you is linear data set, you never show them.
We could ask it what the value of n is.
That will be too easy for it. Equal to these machines.
I know, I'm trying to stop you from picking the hard one.
Has. During training, what does every data point have? What does every data point produce or have? During training, what does every data point have? Let's try that. What sort of hardware are you running this on?
This is on the 3070.
3070, yeah. Good. And
Noon.
okay. Yeah, so that one, it didn't quite do right. So, all right, this is very good. And you got the handwriting part right, you got the receipt part right, both of these. Now, one thing, did you try any of the OCR methods? Like
No.
OCR, easy OCR, or any of those?
We did on a very scaled down version, but I thought it was not the right homework that we were doing, so I threw it away and went to these ones that we have.
Yeah, the point of this partly exercise was to run through the entire history of this field, starting with initial methods of OCR, seeing how it evolves with CNNs, goes through transformers and that. So you might want to, just from a learning perspective, try out those ones. Easy OCR is easy to use. Try out Paddle OCR, Tesseract, and those things. You'll have a bit of environmental issues setting it up. But
understatement.
yeah.
Tesseract was the one that I did do, and it outputted its understanding of all the data.
Mhm.
But then at that point, we didn't have it where we're asking it the question against the text output. And so then I thought, wait a minute, I think I'm not on the right path, and we switched to what we have now. But yeah, we were excited to get these two ones completed and working, and then there's still more in the journey. So
That's right. See, if you want to get from a pure OCR engine to visual question answering, you'll have to do the visual question answering. Namely, you'll have to take the output of the test, right? The CSV, for example, that it produces, and key value pairs or JSON that it will produce based on how you configure it, and then feed it into an LLM and then ask the question.
yep.
You'll have to do that yourself. Okay, excellent work. This is great. Nice to see this, and nice to see somebody is taking notes.
Yes, sir. Sir, I wanted to ask question, sir.
Mhm.
Can it recognize the graph on the paper? If I ask name the axis of the graph shown on the paper, will
We
it give us?
can try that. Let's try that. Would you like to try that?
What is your question you want to ask?
Name the axis of the graph shown on the paper.
Yeah, if you
Th-
use the donut, I think it will be able to answer it.
Yeah, there is a graph, steps and loss.
So
Name
name
the
the
axis.
graph on the
Axis.
paper.
Name the axis. Name the axis. Name the axis of the graph shown on the paper. Yeah, name the graph. No.
No, name the axis. Yeah, name the axis of the graph. And
Maybe it's easy.
well, it wouldn't know if it is a paper. It would say name the axis of the graph.
The image.
That is it. That is it.
Yeah, that's sufficient.
I thought the homework written text, I thought that was a really good example to work with.
Right.
Miso R.
Let's go and look at the image.
It's steps and loss, but it got something, or maybe misunderstood. Loss and steps.
Yeah.
Loss and steps.
Maybe we can be very precise. What is the X and Y axis? What are the X and Y axes of the graph shown? What are the X and Y axes of the graph shown? Let's try that. Nice.
But it definitely makes you think that, oh, I need to know what format is my question going to be in, given the type of data I'm querying.
Yes.
Answer agency.
Ages.
Yeah. So it is incredible. So this is one of the things, guys, you have to always be aware of. See,
Yeah.
whenever you bring in a LLM or whenever you bring in multimodal learning, you have to watch out with transformers. You have to know that the decoder, by the way, it's not just transformers, it's also with RNNs. The moment you bring in a decoder, these things can give you wrong answers.
Sir, can you imagine like old doctor notes? If it can convert unstructured data into structured data, that would be ultimate pinnacle.
Yes. Yeah. But
Nobody,
okay, I'll pose a
nobody.
question for you guys. Sukhpal, maybe for you, I'll pose a question. What would you do to Donut to make it recognize your handwriting?
Fine tune a little bit. Give it some notes,
Yes.
sir.
Hmm?
Because doctor's handwriting, nobody can understand.
Yeah. No, but within reason, actually, you'll be very
Yeah.
surprised how far you can go.
Yeah. Fine
If you
tune.
fine tune on one particular person's handwriting,
Yes.
how far you'll be quite surprised.
We have tons and tons of old notes, sir, in paper files. My God, if we can convert that to structured data,
Yeah.
that would be great.
Yeah. All right, guys. So this is
Thank you.
awesome. Thank you. This is great job, and thank you. And great.
Thanks for being our voice, Lily. Appreciate it.
Yeah, of course. This is wonderful. And Vector Smiths, would you like to go next?
So let me see. No.
Vector
That's okay, we
Smiths
can
had
do
an
it,
interesting
yeah.
adventure.
Yeah.
So, would you like to come here or do it from your laptop?
But we need a couple of things.
Oh.
I'll do it from here.
You'll do it from there. So,
Yeah.
okay, you can do it from there. Then I'll get out of the. So,
No,
guys,
I'll
for
do it
some
from here.
time, I'll get out of the audio. You won't be able to hear me. I want to prevent echoes here.
We're trying to coordinate, we have 3 people can, try to figure out. So
You don't have your presentation coordinated. Okay, I'll leave. But anyway, I'm leaving the audio so you guys can get.
It's better you just go there and talk.
Oh, but I can show only one part of that. Yeah, let me, everybody is having their own part.
I will explain what we are going to show. Yeah, exactly.
So all you have to do is
Yeah.
keep your laptop here and speak into the microphone.
Yeah.
Mute yourself. Keep yourself on mute.
Sure. So yeah, we're going to. Can you hear us? Okay.
Do you want me to share my screen now?
No, I'm going to share. Just hold on. Yeah, we'll come back.
Sounds good.
So we'll show it in 3 parts. The first part, we will show. We tried to do experiment with the donut transformers, and we tried with a few receipts, and something worked. Something didn't work. Rowan is going to show, right?
Okay, I guess so.
And, yeah. Then the next part is, we tried with the second experiment, we tried with the tesseract OCR and parallel OCR that I'm going to show.
Okay.
Where we are. And third part, we try to integrate with LLM, but we are not done it. There are 3 parts to that.
It's not integrated, but I can copy and paste it in.
Okay, we'll see how it goes. Using ChatGPT. Okay. So there are 3 things we can show. So first, you're going to show the part.
Okay.
And the document that what
Yeah,
we
I
tried
can
to do on it.
Okay, cool. Give me 1 second, guys. Okay, Rubies.
Bigger fonts.
Bigger fonts. Ready?
Good.
Yeah. Okay, cool. So first things first, we started with donut, and we particularly went into the donut that was fine-tuned for receipts. So because we assumed that, if it's fine-tuned, then this will work perfectly every time. We were very wrong with that. So after throwing that in, we had our 30-some receipts that we were feeding through. And here are just kind of some examples. So we have an invoice that we fed into it, and you can see like the invoice total $177 here, a little blurry, and it has a bunch of folds into it, which we kind of did on purpose. Then putting that into donut, we get this JSON file, which is completely empty. So from that, it kind of tells us like, oh, okay, something might not be right. It might not be able to read an invoice. Let's see if we throw it in this receipt, which seems super, super simple. So we throw in this receipt, and then we actually get a full JSON. We're like, yes. So from that, we thought that it just couldn't read invoices, and thus it could read receipts. But in the next one, we threw in the Walgreens receipt, and it couldn't get anything. And then we threw in this receipt, and it also couldn't really get anything.
We only got the date and the time from that.
Yep. So using that, we wanted to try another model, because we assumed that this donut model that was fine-tuned on receipts might be too specific to having a receipt in a very particular manner. Of maybe it had to be completely straight, or the background image, we didn't really know on what data it was trained on. So we were like, okay, what if we tried training or using our own donut model and then figuring that out? We ran into a whole bunch of environment issues that we're still currently figuring out on that side. And then when that part of the team was figuring out that part of donut, we then kind of moved to a question and answering using the Naviclova, which is very much kind of like an LLM that you can just feed images into and then ask questions on. And that one we assumed would be a little bit better in the sense of we didn't have to use an OCR and then feed it into an LLM. But we got even worse results using that for the invoice and for using the invoice and using the other receipts. But using this receipt, we actually kind of got an interesting answer that it could kind of read the number. So it's 599 here, but then it says 549 as the answer. But what we notice is that if we ask things that it couldn't necessarily read, it starts to hallucinate. So like when we ask it, hey, what's the tip? And you can see here, tip is kind of like white, it's not completely visible. It's like cooked meat. We're like, huh? And then we're like, okay, maybe something a little bit easier. Like you can see Visa right up here. They're like, okay, what card type did we use? What card did we use? Cardholder agreement. We're like, okay, you don't really understand what the receipt format is. So after trying that for a little bit, then we did paddle. And from the paddle OCR, we were able to get this data, which we didn't quite understand.
This data is based on that second receipt that we saw, which is the parking receipt.
Yes.
So as you can see, it pretty much got everything. It found, the vector positions. So this is what the paddle OCR output is. So these are the bounding boxes, and it was able to give us a very good output of that receipt. That's kind of where we stopped. We were going to take this to a layout LM model, but you rang the bell.
Yep. So then I just copied this and I plugged it into Llama 2 because we didn't have the automatic pipeline. And then doing that, so we asked a couple questions here. So the question I asked is, where did I go? That it kind of took every location as place and said, oh, that's a place, rather than kind of saying all of them had Long Beach in it and saying, hey, you went to Long Beach, rather than just like you went to a parking lot, you went to a hotel. But it was mostly on the right track. But for simpler questions, kind of like how much did I spend? It was perfect, right on the dot. And then out of curiosity, I also threw in the JSON file from the donut one at the beginning to kind of see for this receipt what answer would it give. And it actually kind of turned out pretty well. It's also very simple. The more complex the questions we do, the more it starts to hallucinate. But if we ask very straightforward questions, it seems to work pretty well.
Yeah.
Yep.
That's very good.
Yeah.
Thank you.
So
and then do you want to present your side?
Same thing, but I will
One
show.
experiment you should do is
Yeah.
it's really good. Your receipt that you have, you should rotate. You should say that if I give it a perfect image,
Yeah.
how much difference does it make, especially with the donuts?
Ooh, okay. Yeah, I'll try that.
Yeah. So I want to just finish the.
Do you want me to stop sharing?
Yeah. So
Okay.
almost you covered everything, but
Yep.
a little bit. Yeah, you can just.
Thanks, guys.
Yeah. So for some of us, yeah, good. So how to share? Let me see. Where do we share? Yeah. So in addition to whatever Rowan said, right? In the first experiment, when you take the JSON, I was trying to, when we are multitasking. So similar to what he did for Llama, I tried to feed into OpenAI by giving the JSON. Remember, after the donut is creating the JSON output, by giving some prompt, this is an example, and then answer the question. It started coming, but I had some other issue. But this was the approach we are taking. Take the JSON and do the prompt engineering. Yeah.
So generally, this approach works better.
Okay.
Because a full-blown LLM, you can prefix it with your prompt.
Yeah. Correct.
This is what I did.
You can tell it that this is an invoice.
Yeah.
Right. It will contain these elements.
Correct.
And from that, then you let it, or it will give you some more context. And then the responses you'll get, it will hallucinate less. It will be much more accurate.
Absolutely. So here is for example, here is an example receipt. And in this example, the total amount is this, and there are 3 individual items. So the item is self-explanatory, something like that. You can make that work.
Very nice.
Yeah. So this is one. Sorry.
No, you're good.
So just for, yeah, exactly. If somebody is trying with parallels, we also tried with the tesseract, right? So it was a time we spent 2 hours on that. So much pain. So many libraries and then stuff like that. That's a waste of time. Well, our experience.
Yeah.
We can say it.
Tesseract is,
Yeah.
hopefully, there are enough number of people who have lived in Tesseract hell.
Okay.
Hopefully, the time for it to fade away has come.
Right. All right.
Okay, thank you.
Yeah.
You might want to stop sharing your screen.
Oh yeah. Okay.
Thank you, guys.
Thank you.
And so you guys saw the presentation. This was the quite literally the youngest team. Yeah.
Except me.
Yeah.
You, me.
Oh, okay.
Yeah. All right. So next we'll go to Yeti. Yeti team, are you ready?
We barely have.
Ishant,
Yeah, come by. Show what you have. Whatever you have, show. Yeah, come. You have. It's all yours. You can share your screen.
Yeah. So like I was saying, ours is very short and simple. I mean, most of the time.
A little bit closer to the microphone.
Yeah. Most of the time we kind of spend on.
Wow.
Yeah, most of the time we spent on getting the the environment ready and make the first exercise from the last week to kind of work in our server setup. So we spent quite a bit of time on that one. Eventually, we were able to kind of get that working with the donut model, and then after that, we were basically trying to tweak that donut model to work with the data set that we have for the receipts that we downloaded. We ran into some issues there, and then we kind of tried one of the other models. I forget what was the one we tried. The last one.
Before that, there was one other thing. The paddle OCR we tried, but again, there were some installation issues we ran into, so we kind of gave up on that. And then the third one from the Salesforce that I guess you'll walk through that.
Yeah, first we used the donut model downloaded from Hugging Face, and we loaded our receipts, but we did not get a proper output. It was hallucinating and giving wrong outputs. And then we downloaded the Salesforce Blip, Salesforce Blip BQA model, and tried. That gave better result, but it was not as expected. So basically, we were asking, we loaded a receipt and asked who is the merchant, what is the total cost. It was able to find only the merchant name from a Costco bill. Yeah, we can show a sample output here.
It's having issues connecting to the server.
Yeah, code was running in our room server. For some reason, we are not able to connect.
I want to see if yeah, mine was also slowed down quite a bit. You can see if mine.
do you have your TwinGate up?
No, we have connected through VS Code server.
Yeah, you don't. You should be able to see that.
I have found when I'm using are you using the tunnel, the Visual Studio tunnel?
Yes.
The odd thing I found, because I have 4 machines, that when it freezes like this and it doesn't come in, if I SSH into that machine, it will then launch the server and start running, surprisingly. So I don't know if that will help you, but just an observation.
Okay, yeah. Yeah, so actually we found that when we are able to log in, then what happens is, I think the tunnel server starts. Not SSH, I mean, we were physically logging in from here.
Yeah, that would initiate the same scripts that are starting the service.
So we have,
Do you have a receipt? Just make sure that it's
Yeah, the one with the wrong was the 11, this Vicheta folks. That's the one it didn't pick up.
so we used this receipt first, and we were not able to get any data from here. Then we tried a different receipt.
We used a donut model for this.
The off-the-shelf donut, and when we asked the question, who's the merchant? Here you can see on the receipt, the merchant name is Vijeta. The answer came back Obama.
Then when we went to Whole Foods, here it's much more clearer what the merchant is, and rest of the stuff is not as clear. The thing which we were able to make it work is Whole Foods. The sum total, we tried different words for getting the total here, but we were not able to. And I think in this one, we tried to ask for the number, what is the total, but I have a feeling it probably added up everything, or maybe it is give 25.
25.
So probably added up, or it just spitted a random number, not sure. In this one, when we asked the so here you can see the correct answer, Whole Foods, which we got. Some of the other questions we didn't get a proper answer.
So how happy are you with your OCR software? When is your company launching?
I think the learning for us, the company launching is to set up the environment properly.
I had good develops person.
Yeah.
There you go.
We
That's
probably
what we
spent around 80% of the time figuring out the environment. You know, we installed certain packages and then we had to uninstall and install a different source. I think I forget the package, but you know, first we installed and then we uninstall and then do from Hugging Face a repository and stuff like that. So that to figure that out, it took a lot of guesses and
Initially we were committed to run it with our own pre-trained model, so we spent a lot of time on that and couldn't make it work in the end. So then we went to the models from Hugging Face, and
you gave up too soon. The right approach would have been to pre-train to fine-tune your own model.
Exactly.
That is we are also trying.
We were approaching the deadline too.
Yeah, actually, would you guys? So my question is, would you guys like to persist at it? Take this as a week's project, achieve perfection. I'll give you guys a lot of tips of what you can do. Are you guys game for it?
Yeah.
But come back with perfection next week. I'll tell you the tips. Yeah, be ready to launch your startup. Okay. All right. Which is the next tip? So this is great work.
Thank you.
Yeah. So again, great work, guys. I know that it was a lot of struggle. This team really struggled with the environment quite a bit, and pretty much got the things together suddenly in the last moment. So it's really
two observations, if I can make on Paddle OCR, which we were struggling with. We installed Paddle, and we realized the recent version 2.7.3, which was the released version, did not work.
Yeah.
And then we had to downgrade one and it started working. So that
Which
was
version did you downgrade to?
2.7.2.
2.7.3 has a segmentation fault.
Oh, okay.
So it was giving us a core dump. Core dump.
Interesting. Interesting. So you went back to 2.7. So guys, those of you who I'll repeat what the experience was. In the Yeti team, the experience was that not in the Yeti. You guys were in the, Victor Smith's experience was that if you're using Paddle OCR, stick to 2.7.2.
Yeah.
Don't go to 2.7.3, which is the latest, because that probably will give you a seg fault. On Linux also? On the
Linux.
That's right. Yeah. And I also hear them saying that it gives seg fault for every version on Mac.
Oh.
I'm kidding. All right.
And then the other observation with Paddle is you have to explicitly mention that language is English, otherwise it defaults to Chinese.
Oh yes, Paddle OCR guys, do remember to give the language explicitly as English. And also, by the way, another thing about Paddle OCR, there's something just to remind you. Chinese comes in two flavors, Chinese traditional and Chinese simplified. So they have two different codes. So just be aware of it. Right? And the English, of course, also comes in multiple flavors, but I don't think it matters. If you just say EN is good enough, isn't it? So that's something about Paddle OCR to remember. So guys, I'll give you, there's one more team. After that, I'd like to give you guys a little project for the week. Heisenberg. And what is there any other team after Heisenberg? Element. Okay, so two more teams. So Heisenberg, please come to the screen. And again, guys, this was a great presentation. Good that you guys all tried so much. And let's continue on to Heisenberg. Who is presenting from Heisenberg? I think that. Oh,
We don't have it.
does not matter. Come by.
Yeah, can show this. Right. Am I audible?
Yes.
To the remote team?
Yes, sir.
Right. Thank you.
We can hear you.
Thank you. All right. So you can see my screen. Okay, still the Paddle OCR is trying to download some libraries or maybe like some models. This is going on for almost 2 hours or 2.5 hours. I don't know what is going on there. Okay, so I don't know, like the idea what we had was like taking this Paddle OCR and then just provide the receipts.
Yeah.
And then ask questions so that like we can get some answer from the question. That was the idea. So this was like the third model we were trying to do. The first one actually like the simple one we took was the donut. That's it.
So we actually started with the second project first. So try to convert the handwritten script into the text. So we were able to do that, but we wanted to connect it to the LLM, but that we didn't complete it. Before that, we started with the first project, and then.
Yeah. So this one is using the Hugging Face pipeline approach. We were using that the Naver-Clova donut-based fine-tuned model, just with a couple of lines of code to just try it out first, saying that okay, hey, when we cannot give that receipt, whether we can able to answer the question. So we tried with one image, which is again this image. So, but this is like an existing image, right? So.
What was the total? $59.
Yeah, it was total.
And it got it right.
Yeah, and I asked a question as to what is the purchase amount, because the purchase was not there actually. This. If you look at it, like there is no text called purchase. Like it figured out like, okay, something called purchase or total. So it gave total 59. And I was trying to download another image. It's already copied here.
It's already.
Are you downloading images from the CORD database?
This one is like from the existing database, the data sets, because it is right. Yeah, CORD. But we have some receipts, so we copied here.
Slash img.
This one?
Yeah.
So maybe like we can copy this one, right?
No, it's last time.
Oh, here. Oh,
Yeah.
okay.
Question for that have been presented. Are you guys running these on the 4090s?
No, this is 2090.
Okay.
I don't know what is there in the document, but let's ask the same question. Okay, 2799. Right. So open that file.
I'm just going to print the image.
Yeah.
Yeah, it's just 194.
It is 194.17.
But I think it is picked up something from here.
Okay, let's see what 2799. So it picked up 2799. Okay. Okay, looks like yeah, it like the bakeware. So that's what it should
Can we ask the total? Maybe.
Okay, maybe like we can ask like, yeah, what's the total, right?
Yeah. Yeah.
This is still the donut model?
Yeah, donut
yes,
model.
this is still the donut model. $775. No, it's totally
Why
wrong.
don't you rotate this image? Would you try rotating it and see what happens?
Oh, yeah. Try that one.
I think it's image.rotate or something.
The bear itself.
Rotate.
90. No, 274.
Okay.
Now let's ask these questions.
No, still we didn't get the right answer. Anyway, so this is the limitation. So
So is it because of the glass that are mosaic, those things are okay. So maybe it's so 9.91 is there somewhere, right? If you go up. The first one is
You got the same answer total? Okay.
no, when it was rotated, it picked up something like it from the middle. Something like called bakeware or something like that was 27.99.
so then
Yeah.
if you cut that center image, you can see it better because of the side.
Yeah.
So yeah, there are a few things we can try that basically like we can crop the image or we can reduce the size of the image or maybe like something like that. So probably it might get something, but still this is what we got. Hopefully like the idea was to kind of go from here to that panel and then we stuck with the panel of like downloading the library and other things. So which is still not done. So
yeah, by the way, we also went through the tesseract part as
yeah,
well.
so then
by the time you wake up tomorrow, it will be done.
probably, yeah, I guess.
I mean, interestingly, the size is only 10 MB.
I don't know, some glitch. Do you have, are you doing it on a Mac? Where are you downloading? Where is
On
it?
the
That is like from the server.
It's on the server, but where's your VS Code running?
It's like it's I tunnel to that one. The VS Code, what I'm projecting here, it is tunnel to the server.
Do one thing. On that machine, are you logged in as yourself at this moment?
Yes.
Also SSH to that machine, see what happens.
No, yes.
No, this is to the GitHub tunnel.
No, I know, I understand that. What you're doing is correct. I'm saying in addition to that, why don't you open a terminal and SSH to it?
You guys want to do it? PowerShell, right?
No, that is a local command.
Yeah, but that is using SSH.
No.
It is using it, but some weird thing is there with that if you're on a separate terminal and logged in, sometimes some of these issues disappear. No, just open a Unix terminal and connect to it.
Oh, okay.
From local to there.
Yeah.
Yeah.
Yeah, I think.
So people can
Yeah, the password I don't know.
From outside.
The IP, right? Maybe I think it's not even connected.
Yeah.
It's all right. Maybe you can try that. There's some.
Hey, we're in the recording right now, right?
Yes.
So don't say passwords or other things out loud.
Yeah. Okay, so maybe like we can try later. So the other one, what we tried was like the document Q&A. So we were thinking of doing two-step approach.
Right.
One is like taking that the handwritten document, convert that into a text first, meaning extract the text out of that document, and then feeding it into another model so that like we can ask the question. So that for the question goes as a query, and the extracted content will be the context. So that way like we can get that answer. So that was the idea we had approach. So first thing is like to extract the content, we were thinking about like going with the LMB2 model. So the layout thing. There also we sort of hit the roadblock of something like a Detectron 2 or something like that. Some library was got
It was not installed.
not able to kind of like download, or maybe like we
got this. Model. It takes time.
So, and then we tried with the standard pipeline from the Hugging Face. There also we sort of like got.
There it is asking for the token, like I think.
It's there's one model which was like looks like it's a private model or something like that. So it was asking for the token. So we couldn't able to proceed further. So the approach what we thought about like extracting the content and then like feeding that as a context with a question to get an answer. That was the idea.
Nice. This is good. You guys really struggled quite a bit and made headway. This is amazing. Yeah.
Right.
No, this team really struggled and they put in a lot of effort in it.
Thank you.
Thank you.
Yeah, thank you guys.
As if we are still struggling.
Oh yes. So guys, this team really had a lot of environmental issues for reasons that I'll investigate later why they face so many issues, but they are facing it on that machine. But they stuck to it and they have some results to show, which is quite nice. And there's one more team that's going to present. Listen.
Should I just share?
Just use the microphone, but share your screen.
The measurements.
Okay, I got the handwriting stuff first. It didn't do a great job, but I'll show you the results. So I basically used the TR-OCR, which I later learned from Asif, which that it's a older model, and there are better ones available. So what I basically did is I don't know how to. Okay, yeah. So I basically took some pictures of stuff that I wrote, right, and that's basically what I did. Yeah, and which is even worse than Asif's son. So definitely, it would have struggled. So the cow jumped over the room, number one, and it didn't get this stuff at all. And this one is the Ford jumped over the processor, and then yeah. So if it is vertical, it doesn't even detect it. There's a 0, right? And there's another one. The war jumped over the man, and the cow jumped over the modern. Okay, so yeah. So my handwriting probably didn't. You couldn't do much with it. I should go for a better model, I guess. And one learning I have from this is basically the orientation of the image is important. So even if we have a cross image, we should straighten it using some other model or whatever. And I think cropping helps a lot, because if it's a huge page, it doesn't detect well. So not sure if I'm right, but I noticed that. Yeah. So that was handwriting. Next thing is I took a bunch of my receipts from my car, and I ran this ECOCR, which actually was pretty straightforward, and I didn't have any environmental issues. I was able to pip install and get it running. And so you can see that it is doing a pretty good job of actually drawing bounding boxes and the actual numbers. So you can see then, maybe I'll show a better. This is receipt 7. So I'll open receipt 7. This is a picture I took of my own receipt, and then I cropped it. And you can see that some of the numbers here. It did get some stuff. Yeah, well, probably not this one. Yeah, it didn't get some of the amounts properly, but at least it drew the bounding boxes. So
What model is it?
this is ECOCR, and the code is up here. Well, relatively simple, just few lines of code, and the drawing was the upper part. That and then I started off with MMOCR and parallel OCR, and I got stuck in both. So yeah, that's
Even with MMOCR, the PyTorch.
so I had to install CUDA in my WSL on Windows.
Oh, WSL on Windows.
And I was stuck there. So basically, it.
But you have a Linux, no? You do have a server allocated to you or not?
I have Linux. I'm more comfortable with Windows.
Okay.
And WSL is almost like Linux, so it seems to be working fine.
No, but a lot of the models, no, they are simply not supported on the Windows, no matter what.
But it's not Windows. It's WSL, so it's running Linux. I can run any Linux.
Okay.
Yeah. So far it has been fine. I have not installed CUDA in Linux yet, so I'll figure that out. Yeah. Thank you.
Nice. Yeah, great job. Actually, you nice of you to experiment with so many handwriting variations to see what comes through. So, guys, a couple of your teams haven't presented. I know that people are at different stages of the learning and setup journey. Try to. So, I'll make this proposition. See if it makes sense. Take this as the homework for the week. Would you guys like to take time to perfect this?
Yes.
Right, and share your experiences on the Slack channel. Right, tell each other what libraries you have. Share your sample code if it works, and so on and so forth. Now is the time when we have all tried, and so if something works, just share your Jupyter notebook saying, "Hey, I did this and this worked for me." Right? So that now is the time for collective learning from each other and benefiting from the cohort, social learning. Let's do that this week. Next week, we are going to do image segmentation, which is an important topic. And I've put all the content there on the course portal already. Segmentation itself has a big journey and of very high value, like bounding boxes and masks and so on and so forth, and grounded segments, identifying what it is. There's a lot going on there. We are going to come to that eventually. But Bhavin, you have a question?
Yeah, and before we move off the topic, I was just wondering if you can give some general tips for
Yeah, I'm coming to that.
the accuracy.
Yeah, I'll do that. Yeah. So see, guys, I'll come to that. So next week we'll do image segmentation, and then we are going to go into speech to text, text to speech. We are also going to do diffusion models. Diffusion models are really hot these days. Most of you have played with diffusion models. The topics that I'm sort of, by the way, before I go into the tips, I must also mention I've deliberately not covered certain topics because you guys are still getting fluent with the programming aspect of this project. Become that because the topics in the LLM too are very programming heavy. They are about fine-tuning models, lots of fine-tuning. You will realize that this project was actually, if you really want to squeeze the juice out of it, it is about fine-tuning, right? And pretty heavy fine-tuning to get it right. I mean, you must wonder, for example, how is it that some of these commercial softwares are able to get better results than you are on this topic, right? What is it that they do? So there's a lot of fine-tuning that comes in. We are going to do a lot of that. So most of the topics in the next bootcamp are the same things, but at much deeper level. RAG you'll do very advanced techniques. Prompting you'll do using code, not anymore using the core stuff framework that you use. You'll use some pretty frameworks that are a little bit more abstruse. In other words, people struggle to use those frameworks unless they have substantial programming background. I would encourage you all to get your Python strong before you come for the next bootcamp. There's a reason that I spaced the bootcamp out. After this bootcamp, there'll be a 2-month gap before the next one starts. The lesson to take away is that it's worth getting to master some amount of programming and becoming fluent with it. We'll also do graph neural networks. We'll do some pretty interesting topics. Right? In fact, I could show you what we will do.
Seth, can I share a comment?
Yeah, sure, please do.
So Lily, who's on my team, hasn't programmed before. And as we were doing our homework, I was demonstrating to her, I have Copilot in Visual Studio, and then I had ChatGPT. And I said, if we know what we're trying to get to, I'll oftentimes ask Copilot, I need to do this. Can you show me Python code that can do this? And then it will give me the code samples. And for those who aren't as familiar with Python, it's a really good process because it will give you really good code samples and start to help you with the coding and bridge the gaps. Or if you see some Python code, just select that code and ask your Copilot or ChatGPT, what is this? Explain this to me. And it's an excellent assistant.
Yes, I do agree. So see here, I just sort of assume we all have, is there anyone who's not using a VS Code, the Copilot? If you're not using it, definitely use it, guys. Now, a few tips about, and as Sarah pointed out, You can take the assistance if you know what you're doing, do that. More concretely, I'll give you a tip. Typically, what happens is programmers have the habit of first writing the function and as an afterthought writing the comments, isn't it? The PyDocs or the Java doc or whatever header comments there are. But actually, in this new world of AI and copilots, etc., the right approach is the opposite, actually. You just write your comments first. Write a function signature, write your comments, and then take a few good breaths, and you'll realize that Copilot will essentially emit out the code. So it is a classic act of prompting. You're giving it a prompt, right? The output of the prompt is from that LLM is literally the code that you want. Now, what will happen is about when you're doing regular coding, about 70-80% of the time, you can just take the code as it is. It'll work with minor changes or something. There will be 20% of the time, 20 to 30% of the time. There'll be about 5% of the time when it is completely wrong. Right? And some even in the first, second, third attempt, like you said, this is not try again. It may still get it wrong. And there'll be about 25% of the time in which it will be partly right and you'll have to go and edit it. But it's certainly a big tool to do that. And the best way to look at IDEs now, visual code, if you have integrated with Copilot, and do that, guys. I mean, to go to programming these days without a Copilot integrated, it's like going to accounting exam without carrying your calculator with you. Right? You wouldn't want to do that. So always use that. I think the subscription is fairly inexpensive. What is it? $10 a month. $10 a month. That's a really well spent $10 for programmers. Definitely do that. And assuming that you do have it, think of it. You guys all learned the CoStar framework for prompting, isn't it? So remember that coding has changed now. It is all prompting. All of coding has changed. Prompt, write the prompts in the nice way that I taught you. Write the comments. Your prompts are your comments, right? Remember that comments first. Take a comments first approach. Put your comments, put your prompts. Right? Think of it as prompt. Itemize the steps 1, 2, 3, 4. You should do this. You should do that. The more elaborate you are, the better, right? Put your safeguards and everything. Now, the good thing with Copilot is also, and by the way, Copilot is now beginning to follow a little bit behind some of the local LLMs people use for code generation are even getting more powerful. You can fine tune it on your code bases and your systems. And in my case, I observe that what Copilot does is it has picked up my style of coding. So it doesn't just emit out generic style because it knows that I'll reject it. And so it goes into a very defensible programming. You must have noticed my code that I have preconditions, check, and a lot of type hinting and so forth. So it starts doing all of that. And your mileage may vary, but the more you code, the more it learns from your coding. Right? And some of these tools, they start picking up your coding style. So definitely do that. That is a very, very good point to bring up. So anyway, I'll take a small digression before I give you the tips for this project. See, guys, the part 2 of the bootcamp, right? As I'm going to say, it covers somewhat, the first part covers a territory that is somewhat familiar to you. You guys have all done prompting, but we'll be doing advanced prompting, and it will look nothing like the prompting that you have done, right? It will be very high-powered prompting, and you'll realize that most of the startup, 90% of the startups that are out there are in one form or the other, very clever, very advanced prompting engines, right? They use that quite a bit. So you learn those tools. You will learn RAG also has advanced quite a bit compared to, see, at this moment when you do RAG, I didn't give you any critique, like so long as it works and you're able to produce the answer, it is fine. But as you will learn, that is sort of a baseline performance. You can take a RAG, which is at that performance, to a RAG, which is far better. For example, I don't know if you know Khan Academy, how many of you, well, not you, but your kids are using Khan Amigo as a tutor? What? Moms and dads, your kids are not using Khan Amigo? Okay. All right. So anyway, or Coursera has an assistant and so on and so forth, tutor. So all of these things, they are nothing but RAG engines, right? Very well done RAG engines. So RAG is really worth using. RAG is a no-brainer for enterprise. If you look at the total deployment footprint, the most successful use case for the industry at this particular moment is RAG for AI. See, if you look at the AI mindshare for the last 20 years, it has been the recommender systems, right? Monetization team. Spotify's everything is recommendation. E-commerce sites are recommendation engines. Advertising engines are recommendation engines. Personalized advertising is recommendation. You want to topple a government and send targeted messages to influence the citizens. I'm told that also is just, I mean, I don't know how many of you are aware about Cambridge Analytica and the investigation that was done on them. Guess what did they use? They used the data that the big companies very helpfully gave them, Facebooks and Googles and all of these, and then they created essentially a targeted ad system that knew how to soften people. They convinced Britain to get out of Europe. It was a pretty deliberate act. And there are beliefs that in the US also it was practiced, right? And one of our elections was affected. It certainly has been tried in many other countries with great success. Cambridge Analytica claimed that they can hand over election to whoever is willing to pay for it, pay for their services. Well, I don't know what happened to that company anymore, but those were powers of AI, but that is very old generation AI. If you look at the generative AI, the big thing that's happening these days is, or the one use case that is dominating the scene, every single company is adopting is RAG. Right? So you learn a lot of RAG techniques, then we'll do a lot of building models from scratch. At this moment, I'm not asking you to build models or even fine-tune, very baby fine-tuning models, but you'll learn a lot of building models from scratch and fine-tuning those models. Right? You will learn what is the gap between a GPT and what makes a GPT into a chat GPT. Right? What is the whole journey for that? You will see that people are able to build an entire textbook, literally on any topic, catering to any audience, just using the techniques that you learn. You will learn a lot of fine-tuning techniques, a huge amount of fine-tuning techniques. Again, that will be code, right? You will learn some things in reinforcement learning and human feedback, human preference alignments and so on and so forth, some of that. But the most, and then we'll end that course with two big things which are there. Just as last year was the year of chatbots, 2023, right? 2024 decidedly is the year of agents. Is the year of the agents. Multi-agent orchestration. Any problem that you solve with one LLM, quite likely it can be solved. Very often it can be solved with a multi-agent orchestration much, much better. By the way, including the problem that you're solving today, that's a hint. Right? Okay, so then graph neural network is another very hot topic. At this moment, by the way, anybody who knows graph neural network, like, I think by the time you update your LinkedIn profile with those skills, graph neural networks and these complex network analysis and so forth, you wouldn't even have time to finish your coffee before you start getting your the email chains from recruiters. So these are hot topics. You'll come to it. I'm assuming that you guys will all spill over to the part 2 because this is just getting you warmed up to the real thing. But the reason there's a 2 months gap is become good at coding, guys. Are we together? Become reasonably good at coding. You won't be able to do that. And frankly, these sort of techniques, once you master, you'll be ready to do your startups or lead teams. But you can't do that. Yeah. At this moment, it's an introduction. Good, you got introduced. You can do a lot of useful things, which is good. I have sort of avoided programming. This was the first session in which I expected you to do coding on your own. But even that was straightforward. You were looking at examples online and playing with it and copying it and so forth. But that won't be the territory next time. I'll do that. But so use your co-pilots, use whatever tool it is, but become good at coding. It doesn't mean that you have to be super gurus at coding. It just means that you have to be reasonably fluent at coding, in particular, Python coding, right? That is that. Oh, by the way, just a show of hands, how many of you are likely to be in part 2?
Yes.
Okay. So yeah, I expected that. That's what happened to the last batch. Almost all of them were there. And
What's the time frame?
it's the same thing, 3 months.
No.
Oh, when will we start? We will start in quite likely mid-July. So you have 2.5 months to catch up. And also I'm aligning it to the fact that a lot of people travel to India, to their home countries, July, August. So I mean, if needed, I'll make it early August, but that's when it will start. I believe this, the last class for this is sometime in first week of May or something like that. We have today is which session? 8th or 9th? 8th. Today is the 8th session. So yeah, 4 more sessions. So that's that. All right, guys. So now I'll come to the topics for, and by the way, I hope you can see that it picks up pace. Right? These bootcamps pick up pace in the next LLM2, right? So there'll be a lot more covered in that. So be mentally ready for that. You'll learn a lot, but at the same time, you'll have to gear up for it. So make sure that in the summer, you review everything you learn here and come prepared for the second part. Okay. Now, coming back to our thing, see guys, no problem. Let me just say it this way. No problem should ever be solved as one-shot problem. When all of you were trying this, we all get into the habit of looking onto the web. Web is full of POC code, right? It's proof of concept code because people are explaining to you how to use a model, right? To learn for teaching purposes, that code is very good. Hugging Face has very good documentation. But the expectation is not that you'll use it as it is in real world. Yeah. In real world, you need to create, guys, pay attention. In real world, you need to create a whole pipeline of things that you do. So for example, if your receipt is what it is, guys, please pay attention here. If your receipt is the way it is at an angle. I deliberately say, what if it is an angle? What is the first thing you should have done? Rotate and aligned it, straightened it. If it is at an angle, you have to flatten it, right? You should have flattened that image. And there are tools to do that. You can do that. There are you guys, some of you had glare on your images. How many of you had glare in your images? Glare. You can unglare it. Computer vision and image processing has been a mature domain for many, many years. So just because you're doing things with transformers doesn't mean that you forget all about all those techniques. You can sharpen. You know that there is text in particular, isn't it? Specifically, there is text. So what can you do to edge detection? Can you sharpen the edges, sharpen the images, right? Increase the contrast. You can play with all of those things. It is worth doing that, isn't it?
Yeah.
Right.
So that is, I think, like that's we consider that as a second part. First, we need to get that like the pipeline to work.
Yeah. So this is good. Can I give you guys this task that take a week? Each of you guys come back with a better version of what you have. Do you think that's worthy to do, worth doing it? Share your results on Zoom. I mean on Slack. Time permitting, we'll do another show and tell, but if time doesn't permit, we'll have to move on to the next topic. I will give 5 minutes to each team to show and tell. How's that? Next week, we'll start with a show and tell for 5 minutes to see what progress we have made. 5 minutes per team. Does that look reasonable, guys? Right?
Yeah.
5 minutes per team.
Yes.
Yeah.
Also for the, in the situation on the accuracy part, where it's like just predicting the wrong names.
Yeah.
Like what kind of fine tuning or what kind of adjustments you can think about to get it to give you the right answer?
No, that's a good question. So Bhavin is asking, when it is literally giving you the wrong answer, how do you know that you can trust it? And what are the limits of trust here? That how correct it is. And I'd say I can give you the answers to that, but I would rather that you guys experiment it. I'll give you the answer next time. Right? But I think you'll find the answer before I give it to you guys. As you play around with it, you'll know the answer a little bit. Or have a pretty good sense of the answer, yeah.
So for the document question answer problem, problem. You said that okay, the TR OCR model is old when we try that one.
It's not that old, but it's relatively, but okay.
Because when I go to Hugging Face, when we are sort of like a browsing in terms of like the number of downloads and other thing, that is one of the things which has like a pretty good downloads.
Yeah, because OCR is entrenched in people's mind, and if you are going to do OCR, TR OCR is one of the state-of-the-art models. Yeah. The question that I was asking you is, do you really need to do OCR sometimes?
Okay.
That's the thing, from that perspective. But assuming that OCR is there as a fact of life, if you look at the title of the paper, Donut, what is it? OCR free.
Yeah. Okay.
So that's another way of thinking, that's maturing. But if you want to stay within the OCR first, and then the downstream tasks, then TR OCR is certainly amongst the state of the art.
Okay.
Amongst the most popular models. Go ahead.
Before we were talking about like sharpening the images before inputting them, right? So will improving the quality of the image still like allow the model to learn how to like fine tune or whatever that is? Like will it still help it learn?
See, that's a good question. If you're fine tuning, you have to ask what is reasonable and practical pre-processing of the image you can reasonably expect a user to do, right? And aligning the orientation, getting it right, those are basics you can expect. Yeah? Sharpening it a little bit, those are okay. And so you can feed it images. See, when you're talking about receipts, the state of the art is not that great. It is at the level that with a lot of effort, you can make it good. But there still remains an error rate. Are we together? There still remains a part at which there's some human verification that is needed. Yeah? And your goal is to minimize the human verification cost. So the more you can extract from the image automatically, the better. That is another aspect of it. Like, for example, in this model, because you're using a baseline version, you don't know what is the confidence. How confident was the model? But you realize that models can tell you how confident it is about its answer. LLMs tell you, whenever it produces tokens, it tells you how confident it was in producing that token. You can look into that also. Anyway, those are some of the thoughts. It's 5 o'clock. I will, are you guys, I mean, I was going to do 2 research paper readings, but how many of you have completely fresh minds and we should do it? No?
No.
Yeah. Oh, I saw 2 hands. Yeah. That's a majority. I'll go ahead.
Oh, 3.
No, okay, I'll do it next time, guys. We're a little bit behind, but I'll start with those paper readings. Those were the classic papers. I put it on your course portal. By the way, they go to the topic of all right, let's keep it for the next time. I wanted to at least get started with image segmentation. What am I in? No, not this course. By the way, one request for you guys. If you like this course, if you're benefiting from it, I know today none of you would agree because you all have a frustrated look on your face, right, with all these libraries. But do help us get the word out. We don't have an advertising, sales, marketing machine. Everybody who comes here comes by word of mouth. So if you can please pass the word out, I'll appreciate it. And oh, yeah. So